Hello, everyone. Welcome back. Let's see the chapter 2.3, more functions under graphs. In this part, let's see increasing, decreasing, and constant functions. A function is increasing. So look at the first graph. This is increasing graph because it's going up. And then how to decide if the function is increasing. So we can pick 2 points. First point here, second point on the graph here. The first point, x is x sub 1, and the y's value is f of x sub 1. Next point, x sub 2, you see, from the x sub 1 to x sub 2, x value is increasing. Then the y's value for the x sub 2 is f of x, so f of x2. Oh, x value is increasing, y's value is also increasing. That means this function is increasing function. Let's see next graph, decreasing. You see it's going down, this is decreasing. But how to define that? First, we pick 2 points. First point, x sub 1, and second point is x sub 2. You see x value is increasing, but the f of x sub 1 is here, and the f of x sub 2 is here. So y's value is decreasing as the x increasing. This function is decreasing function. Constant function, next one. You see x sub 1, x sub 2, all of them, they have the same y's value. That means y keep the same. I don't care what is the x value. This is constant. Okay, let's determine the functions interval, which is increasing or decreasing. Increasing and decreasing functions interval, that means all the x value. Let's see the graph here. The graph, half of the graph is decreasing, half of it is increasing. So let's use different color, highlight the increasing. So from this point all the way to the right is going up. This is increasing. And this side is decreasing. Okay, so the increasing is starting from the x value is -1 to infinity, because increasing the red part, the starting x value is -1, and then all the way to the past infinity. So here we must be careful. For the increasing and decreasing interval, we use parentheses. We never have the bracket. Okay, let's see the decreasing interval. Decreasing interval, that's the blue curve here. That's from -infinity to -1, parentheses. Do we have constants? No, constants means it's a horizontal line. There's no horizontal line, so no constant. Let's see second graph, increasing interval. From the first point all the way up, we only have one so we only have one curve is going up, one behavior, that's increasing behavior. So the increasing interval, all the x value starting from 0 to infinity. And here, be careful, we have parentheses for all the increasing, decreasing interval. No decreasing and no constant. Let's see next one. So next one is a segment. It's a decreasing segment. It's a line. So is there increasing interval? No. Yes, we have decreasing interval. The starting point is here and the point is here. So the x value for this point is -2. The end point, x value is 6. So we use parentheses contain these two numbers. Constant, no constant. Number 7, increasing, decreasing, and constant interval. Do we have increasing interval? Yes, we have. So we can use the red one, highlight the increasing part. And the increasing interval is starting from -infinity to -1, parentheses. And is there any decreasing? No, no decreasing. Constant, we can use different color. We use blue, highlight this area. This is constant. The starting point x value is -1, -1, infinity. Okay, let's see number 9 and number 11. Number 9, we have 4 parts. We can separate it into 4 parts. Let's highlight the increasing interval. So here is increasing, and from this point all the way here is increasing. Decreasing, decreasing. Let's identify the increasing interval. Interval is starting from -infinity to 0.0. So that's the first red curve. That's the first red curve here. And the second red curve is from 1.5 to 3, x value. 1.5 to 3. How about decreasing? Decreasing is the blue curve here. So the decreasing is from 0 to 1.5. And the second interval is 3 to infinity. Is there any constant? No, there's no constant. Okay, let's see number 11. Increasing interval. Let's highlight increasing part. Okay, these 2 segments, they are all increasing. So the increasing is from -infinity, sorry, x value. From this point, x value is -2 to the end point here, x value is 4. Decreasing, is there a decreasing interval? No. Constant, yes, let's highlight the constant, this horizontal line, this horizontal line. The interval notation is from -infinity to -2. And another side, we also have the horizontal line. That's from 4 to infinity. Okay, let's see relative maximum and relative minimum. Relative minimum and maximum, we also call them local minimum or local maximum. That means it's not universal minimum or maximum. For example, look at the graph. If I continue to graph it, it's all the way going up or going down. So the maximum for the graph or for the function is +infinity, and the minimum is -infinity. But we're not talking about universal maximum and minimum. We're talking about if I use a box contain this area. So I just took a picture, take a picture of my graph. I cannot take all of the picture of the function because it's all the way going up and going down. So in this picture, the dip and the bump represent the relative minimum and relative maximum. So this bump we call relative maximum. This dip we call relative minimum. So sometimes we are not only have one maximum and minimum. For example, if the graph is like this, oh, sorry, this looks very crazy. So we have 2 dips. We have 2 relative minimum. We have 1 bumps. For example, this is a bumps. And this point is relative maximum. Okay. And remember that relative maximum and relative minimum, they all mean the y's value, because you see the dip and bumps, they are all the y's value dip and bumps. So the minimum, relative minimum and the maximum, that means what is the y's value at this point? Let's look at the graph here. What is the relative maximum? That's the bump here. And the y's value at this bump is 4. But you can also put more information. At the x value equals, so this point x value equals 0. You can say y equals 4 at x equals 0. Relative minimum. These 2 points, they are 2 dips, and they are the relative minimum. And y's value at the local minimum is 0. And the x value, one x value is x equals -3. Another x is +3. Okay. Let's see next example. Next example is a combination example. Look at the graph. What is the domain of the function f? Domain means all the x value. Why am I writing this? So let's write all the x value. Look at the graph. I have a mark here. All the way going down. So x value, this graph, all the way going down, the x value is from negative infinity, and all the way to the end point here, the x value is from negative infinity to +3. Oh, this is 5. Use brackets because this is a domain, it's not increasing, decreasing interval. So we can have 3 included in the domain interval. Okay, what is the range? Range means all the y's value. We can find what is the lowest point and what is the highest point. Lowest point, we can say that's negative infinity. And then highest point is here. The y's value is 4. Better looking for. We use brackets. The zeros of the function. Zeros of the function means the function equal to 0. Function equal to 0, that means y equal to 0. On the graph, we have 2 points here. The y's value, they are 0. At y equals 0, f function equal to 0, what is the x value? X equals, this point is -3, and another point x equals +3. Number D, f of 0. F of 0 means input 0, x equals 0. Look at the graph. Where is the x equal to 0? Is a point here. This point x equal to 0, y's value is 3. Number E, intervals on which f is increasing. So we can use different color, highlight increasing interval. So increasing part, all the way to the point here. This is increasing. And the interval of increasing is from negative infinity to the point. The x value is 1. Use parentheses. Increasing, decreasing interval means x interval, all the x value of the increasing. Second, intervals on which f is decreasing. We can use different color. So from here to here is decreasing. So decreasing interval is from the x equals 1 and to x equals 3. All of them, they have parentheses, not interval. Let's read the next question. G, value of x for which f of x is less than or equal to 0. And here we must be more careful. Let me clear the graph. For the function f of x less than 0, that means y's value equal to 0. Let's highlight the function y less than or equal to 0. Yes, I have this area. And what is the meaning equal to 0? Equal to 0, that means that's y equal to 0. Let's see this point. And then this point also have the y's value equal to 0. Oh, that means the x value could be from negative infinity to 0.3, -3. Brackets, because this point is included in the interval of the f of x less than or equal to 0. And also we have another point has the y's value equal to 0. We need to union an element x equals 3. Because this point x is not interval from somewhere to somewhere. It's just one element. We should list the 3 in the set notation. So put the 3 in the braces. That's 3. Okay, let's see next part. Any relative maxima and the numbers that which they occur. So maxima means the bump. We have the bump here. So the bump here, y's value is 4. And also you can put more information at x equals, that point x equals 1. Number I, the value of x, which f of x equals 4. Okay, y equals 4. That's also the maximum here. So this point f of x equals 4. What is the x value? X equals 1. Last question, f of -1, positive or negative? So where is f of -1? On the x-axis, this is -1. So the point must be here. This point has the y's value, f of -1 is 2. So that's a positive value. You can circle the positive, or you can put a positive sign here. It's a positive solution. Okay, this is a short video. If you have any question, please contact me. Have a good day. See you next video.